continuing with the second unit of the ninth class. We are studying is matter around us pure. We are considering few more questions. Question is define suspensions. Suspensions are defined as the heterogeneous solutions where solute is suspended in the dispersion medium or a solvent, and the particle size in this case that is more than that of 100 nanometer, and the particles are quite large in size. They can be even seen with the naked eyes, so these are called as suspension. Then we have the next question. Classify. This is a question. Classify each of the following as a homogeneous or heterogeneous mixture. Now we are given with some solutions, so we have to identify whether they are homogeneous or heterogeneous. For example, we have soda water. Soda water is a homogeneous mixture where carbon dioxide gas that is dissolved in the cold drink. Then we have the wood. It is also a heterogeneous mixture of many polysaccharides, carbohydrates, cellulose, etc. Air is a homogeneous mixture. Whatever the gases are present, they are homogeneously present throughout each other. Then we have soil. Soil is also a homogeneous mixture. Soil is also a heterogeneous mixture. Then we have the vinegar. Vinegar is a homogeneous mixture. Then we have filtered ice. It is a homogeneous mixture. Then how would you confirm that a colloidal liquid given to you is a pure water? So that a colorless liquid given to you is a pure water. The pure water confirmation can be done by taking the boiling point of the water or the melting point of the water. If boiling point and melting point they remain the 100 degree centigrade and melting point remains 0 degree centigrade, it is thought to be a pure liquid. The pure substances, they do not show variation in their melting point and boiling point, which should match with the literature value. Then which of the following materials fall in the category of pure substances? Then ice falls in the category of pure substances because it is a water whose physical state has been changed. Then milk, it is a homogeneous mixture. Then iron, it is a pure element, it falls in the category of pure substances. Hydrochloric acid falls in the category of pure substances. Mercury falls in the category of pure substances. Calcium oxide, it falls in the category of compound, which also comes in the pure substances. Then air does not fall in the category of pure substances. It is a mixture. Then identify the solutions among the following mixtures. We have to identify the soil, whether soil is a mixture or not. Soil does not come under the mixture category. Sea water, it comes under the category of mixtures. Then we have air is also under the category of mixtures. Coal is not under the category of mixtures. Then we have the soda water comes under the category of mixtures. Which of the following will show the Tyndall effects? Tyndall effect is shown by colloidal solution. Let us see which is a colloidal solution here. The categories given here are salt solution, it is a true solution. Milk is a colloidal solution. Copper sulfate solution, it will be a true solution when copper sulfate dissolves in water. And starch solution, it is a colloidal solution. Then we have the question, classify the following substances into elements, mixtures and compounds. Sodium comes under the category of pure element. And then soil comes under the category of your mixture. Then we have the sugar solution that comes under the category of mixture. Silver is a metal, it comes under the category of an element. Calcium carbonate is a compound. Then we have tin is a element. Silicon is a element. Coal is a mixture. Then air is a mixture. Soap, it is a compound, it is sodium salt of fatty acid. Then we have methane is compound. Carbon dioxide is a compound. Blood is a mixture of number of component. It contain RBC, it contain WBC, it contain platelets. plasma, etc. Then we have the question, which of the following is a chemical change? Growth of a plant. Growth of a plant is a chemical change. Rusting of iron, it is a chemical change. Mixing of iron filling with sand, that is giving us the mixing of iron filling with sand, that gives us a mixture. Then we have cooking of a food, it is a chemical change. Digestion of food is a chemical change. Freezing of a water, it is a physical change. Then we have the burning of a candle, that is a chemical change. Now we will be doing some MCQ question, the questions which are having multiple choice. For example, first of all we take that pure water is, what is pure water? It is a compound. Then we have the a colloidal solution has one phase, two phase, three phase, four phase. A colloidal solution has two phases. One is solute, the substance which is dispersed, it is called as dispersed phase. It is equivalent to solute of the true solutions, and the medium in which the dispersed phase is suspended, that is called as dispersion medium. So colloidal solution, it consists of two phases. One is dispersed phase, another is dispersion medium. Then we have the question, the size of colloidal particle is, it lies between 1 nanometer to 100 nanometer. That of suspension is more than 100 nanometer, and that of true solution, that is 1 nanometer. Then colloidal particles can be seen with, they can be seen with the ultra microscope. Sometimes some colloidal particles, they grow in size, they reach up to 100 nanometer. They can be seen with the naked eyes. Now, which of the following is a element? You are given with diamond, HCl, ice, and air. So we can say diamond is a pure form of carbon, so it is a element. Which is a compound? Air, ice, water, or your copper. So we can say water is a compound. Tyndall effect is shown by, it is shown by the your colloidal solution as well as by suspensions. Then we have a pure substance can be a element as well as compound. Sugar can be extracted from aqueous solution through crystallization, where water will evaporate, leaving behind the concentrated liquid, which is called as mother liquid. This liquid is kept for cooling for some time. Then crystals of sugar, they will be separated from the solution. Then he says, which represents mixture. You are given with the choice ice, ice cream, then we have calcium oxide and mercury. As we know, air is a mixture, calcium oxide is a compound, mercury is an element, hydrochloric acid. So we have pure substance in this case will be which is which is not a pure substance. Air, hydrochloric acid, and then calcium oxide and mercury. So we can say air is not a pure substance. Then which represents a mixture, that is ice cream represents a mixture out of ice, ice cream, and your diamond and graphite. Then which is not an element, you are given with the choice diamond, brass, silicon, and hydrogen. So brass is not a element, it is alloy of zinc and copper. Then a pure substance is out of following: soda water, soil, brass, and liquid. Liquid is a pure substance, it is in the form of water. We have H2O. What is chemical change? Growth of the plant. Given choices are growth of the plant, melting of the ice, boiling of the water, evaporation of the water. So growth of the plant is a chemical change which is caused due to many hormones which are chemical. They are cytokinin, they are gibberellin. Then we have the physical change is what? Cooking of food, it is not a physical change, it is a chemical change. Growth of the plant is a chemical change. Melting of ice, it is a physical change. Digestion of food is again a chemical change. Homogeneous mixture out of following, you are given with the choices: soda water, air, soil, and vinegar. Soil is a homogeneous mixture. Sugar contains the element carbon, hydrogen, oxygen होता है sugar में. We have the formula C12H22O11. Then brass does not contain gold, copper, zinc, and none. Brass does not contain gold, it contains copper and zinc. An emulsion is made of how many, whether it is made of solid solid, liquid liquid, gases gases. So emulsion is liquid liquid solid, where one liquid is suspended in another liquid. For example, milk is an example of a emulsion where fat particles they are suspended in the water. Similarly, we can say the vanishing cream, it is also an example of emulsion where fat particles are in larger proportion, water is present in a small proportion. Then solid emulsions, they are called as alloys. They are prepared by mixing the two solutions of two elements. Alloys are considered to be the mixtures. Air is a homogeneous mixture of number of gases. Then we have the main constituent of air, that is nitrogen, 78% by volume, 20% oxygen, remaining gases are argon, krypton, xenon, radon, etc. Then air is a mixture, that is a gas suspended in gas. So gas is gas, it is called as the true solution. Then we have an example of homogeneous mixture, whether it is copper sulfate in water is a homogeneous mixture. Chalk suspended in water, it will give us the suspension or colloidal solution. Both types of mixture they are possible here. Which one of the following has fixed boiling temperature? They are colloid, mixture, true solutions, or compound. Compounds have fixed boiling temperature. They are not colloid, they are not mixture, they are not the true solutions. Then we have a mixture of oil and water that can be separated by using separating funnel. It is a huge funnel where this mixture is put and it is shaken well and kept for some time. When oil form a separate layer on the upper side because it is less denser as compared to water. Water forms a lower layer in the separating funnel. Then which method helps in separating ammonium chloride from sodium chloride? Ammonium chloride being sublimizable compound, when this mixture is heated, ammonium chloride will evaporate. These vapors are collected by keeping an inverted funnel with having cotton stem, cotton plug in its stem as a plug. Then funnel is taken out, it is scratched to get back the ammonium chloride. Sodium chloride will remain in the pan in which they were heated. And then a simple fractionating column tube is packed with number of glass beads. It is having number of glass growths which are providing obstruction to the upcoming vapors. The vapors which are formed at a low temperature less than their boiling point, they get condensed in the bulbs of these fractionating column and they get reverted back, while the vapors which are formed at their actual boiling point, they are coming out of the fractionating column. In this manner, the mixture of two liquids they can be separated by using a huge fractionating column. Which method is used to separate the various components of the air? The various components of the air, they are helium, neon, argon, nitrogen, oxygen, krypton, xenon. They can be separated by fractional distillation. Then we have who use the term element for the first time. The first time the element term was used by Robert Boyle, who gave Boyle's law, and then named the gas with the smell of rotten eggs. The smell of rotten egg is possessed by the gas H2S. H2S is hydrogen sulfide gas which possesses the smell of rotten eggs. Then we have the next question, what are aqueous solutions? The solutions which are prepared in water, they are called as aqueous solution. For example, we have sugar, water solution. This is aqueous solution. Salt water solution. This is aqueous solution. So these are aqueous solutions. Then we have what are non-aqueous solutions. Solutions where solvent is not water. What are alcoholic solutions? Solutions which are prepared in alcohol. They are called as alcoholic solutions. And what are aerosols? The colloidal solutions, where air is dispersion medium or solvent. Example, dust in air, it is called as aerosol. Fog, it is water vapors in air. So these are the few definitions. Then we have what are unsaturated solutions. Question number 6 is what are unsaturated solutions? Unsaturated solutions are those solutions which have the capacity to dissolve more solute. They are not reached up to the saturated state. Now, what are supersaturated solution? A solution which contain more than the capacity of the solvent, more solute as compared to the capacity of the solvent. So they have more solute than saturated state of the solution. They are called as supersaturated solution. It is highly unstable solution. Then we have what is gel. Define gel. These are the solid colloidal solutions where dP becomes more than that of dm, and this solution acquire the solid shape. Our nails, our hairs, they are, and horns of the animals, they are the examples of gel. Then we have defined emulsions. We have already defined emulsions. Emulsions are the liquid sol. They are of two types: oil, water, where oil is minor component, water is the major component. Then we have water oil emulsion, where water is minor component and oil is the major component. Then we have the question, name a mixture used by all living beings. Air we are using all for breathing. Then we have in the construction of building we are using cement. Then we are using milk as a food item. Then we have give two examples of each case. Homogeneous solid mixture, we have already defined this case. Homogeneous solid mixture, that is a mixture of brass and bronze, or we can say the mixture of zinc and your copper. Then sugar in a mixture of solid in liquid, we have sugar in water, salt in water, that is a mixture of solid in liquid. Then mixture of gas in a liquid, carbon dioxide dissolved in cold drink water. Then we have heterogeneous solid mixtures. These are the gunpowder, which is having sulfur, charcoal, iron and sulfur. What liquid would you select to remove sulfur from a crucible? We will use CS2, which combines with sulfur to produce a complex CS3, and this is separated from the crucible. Later on, CS2 is separated from the sulfur by using suitable technique. Then we have give two advantages of paper chromatography. First is it can be applied even to a very small amount of mixture of the substance. The component of the mixture do not get wasted during the separation. They are not wasted at all the component they get separated. Then we have how will you obtain a sample of sulfur from a mixture of sulfur and your carbon? So shake the mixture of sulfur and carbon with carbon disulfide, which will dissolve sulfur and will leave the carbon. Carbon is separated through filtration. Later on, sulfur is the carbon trisulfide compound so formed between the reaction of CS2 and S. When it is heated, it will separate the sulfur from CS2. Then the process would you separate to collect separate and then collect alcohol from a mixture of alcohol and water. A mixture of alcohol and water, it can be separated by using fractional distillation. Then we have the what process would you use to separate? What process would you use to separate a mixture of iodine from impure iodine? It is sublimation. When impure iodine is heated, iodine get vaporized. These vapor they get cooled in the inverted funnel kept above that pan, and these vapor later on scratched out, get solidified in the separating funnel from where they are taken out and are scratched out. Now petroleum is a dark viscous liquid. Why it is called a mixture? Petroleum is a dark viscous liquid or large number of hydrocarbon. The hydrocarbon, they may be kerosene oil, they can be diesel oil, that can be lubricating oil, petrol and benzene and naphthalene. Number of fractions are there, that's why it is called as a mixture. Arrange the following present in the air in increasing order: nitrogen, argon and oxygen. So maximum percentage of compound, that is oxygen in air, and then we have the argon, nitrogen. Arrange the following in order of increasing their boiling point. Their boiling point: oxygen has the maximum boiling point out of argon, nitrogen and your oxygen. Argon comes second and nitrogen has the least boiling point. If we see the percentage, we have already defined 78% by volume in the air is nitrogen, then we have 20% oxygen and other noble gases, etc. Which out of the following, nitrogen, argon, oxygen, will be liquefied first? And oxygen will be liquefied first because its boiling point is more, its critical temperature is less. Then we come to the next few more questions. Give few important characteristics of the pure substance. It is homogeneous, it has definite set of properties. A pure substance cannot be separated into other kinds of matter by any technique. A molecule can be formed by element as well as compound. Explain. So a mixture can be formed by your element as well as compound. Explain. So we can say mixture can be formed, element and compound, they are both pure form of the matter, and when they are mixed in any ratio it will produce mixture. And the constituting particle in case of both, it can be molecules. Some elements such as noble gases, they exist as a monatomic molecules. So when noble gases they are mixed together in any ratio, it can give us the heterogeneous mixture. Similarly, compounds, they can also give us the heterogeneous mixtures. Then give three characteristics of mixture. Mixtures, its components of the mixture, they are present in any ratio, they have no fixed ratio. It can be homogeneous as well as heterogeneous, and mixture can be separated to its constituent by physical or mechanical methods. So this is all about this lecture. In next lecture we will take in some other questions.